Hello everyone, I am Yudhishthira. I would like to welcome you all to my YouTube channel WonderChem. The reason for me to start this channel is to provide a video synopsis of the chemistry topics of 11th and 12th grade and make the topic easier and better way to understand. This will be helpful for the students to crack their competitive examinations as well. Now, the topic for this particular session is classification of elements and periodicity in their function. Now, in this particular topic, we have lots of things which have been discussed. That is, it could be the history of periodic table or the laws given by the chemists, or even the nomenclature of elements having atomic number greater than 100. Now, when you look into the important aspects, I only see these physical properties of these elements to be more important. That doesn't mean that the other topics are not important, maybe of lesser importance. So let's start with this. So in this physical properties, we have atomic radius, electronegativity, electron gain enthalpy, and ionization enthalpy. If you observe, I have marked them as S1, S2, S3. These are the 3 sessions in which I'll be covering this particular chapter. And in this session, that is in S1, I'll be covering atomic radius. Now, when you look at atomic radius, with the knowledge of geometry, what we have, we can say that radius is nothing but the distance between the center of the nucleus to any point on the circumference of the circle. Now, in this case, this is the radius of this particular circle. But we know that atoms are 3-dimensional in nature. So, if they are 3-dimensional, they'll be spherical in shape. So, even for a sphere, the distance between the center and any point on the surface is the radius of this particular sphere. Now, with this knowledge, I can say that the atomic radius can be defined in this way. In an atom, nucleus will be present in the center. So, the distance from the nucleus to the outermost electron, we know that electrons are present in this orbitals which are present outside. So, the distance between this can be called as atomic radius. So, a proper definition for atomic radius is the distance between the center of the nucleus and the electron present in the outermost orbit. Now, we shall continue. Atomic radii. Now, when I say radii, it is the plural form of radius. So when you look into this, you can find that there are different radius which can be studied. So talking about this, we know that elements do not exist in free form. They are present in combined form. When I say combined, they have to be bonded. They can be covalently bonded or ionic bond, metallic bond, something like this. So we look into different radii. So it can be covalent radius, metallic radius, ionic radius, and also van der Waals radius. So let us discuss in detail about these. So when I say covalent radius, I consider these 2 atoms which are covalently bonded, and this distance between the nuclei of these 2 atoms is called as the internuclear distance, and they are covalently bonded by sharing electrons. So we can define covalent radius as the half of the distance between 2 atoms when they are bound together by a single bond in a covalent molecule. So this is nothing but covalent radius. So the next thing is about metallic radius. We all know that these metal atoms are present in their crystal lattice. So when I say crystal lattice, it means these two atoms, or which we have considered over here, are the adjacent atoms in their crystal lattice. Now, this is the interatomic distance, and the half of this is the metallic radius. So let us look into the definition of metallic radius. It is the half of internuclear distance between metal cores in a metallic crystal. Next thing is about ionic radius. Now, before I start with this, I would like to define what is an atom, what is an ion. Atom is electrically neutral, whereas ions are electrically charged species. They can be positively charged or negatively charged. Positively charged species are called as cations, and negatively charged species are called as anions. Now, the definition part of this. The distance from the center of the nucleus to the outermost shell, which contains the electron, is the ionic radius of it. Now, when it comes to cation, it is the distance between the center of the nucleus and the electron present in the outermost shell. Now, if I have to explain about this, this yellow boundary is the actual radius of the element. But after losing an electron, the size of this atom shrinks and becomes a smaller one. Now the new boundary is this orange mark. Now, because it has lost an electron, it has been positively charged because the number of protons remain the same, but one electron is lost. So the net charge of this atom is now positive. So it can no more be called as atom, it is a ion. Whereas if you look at the anion, it is by accepting a new electron, it has become negative in charge. Therefore, the new boundary, or the distance between the center of the nucleus and the electron in the outermost shell, is this, the new orange boundary. So this distance is the anionic radius. So to tell you about this, we can infer that radius of a cation is smaller than the parent atom, that is what we saw over here, and radius of anion is larger than the parent atom. Now, if we have to look at the overview of all the radii what we studied now, first thing is about the covalent radius. I have taken chlorine molecule as an example. Then for metallic radius, I have taken sodium atom. Then for ionic radius, I have taken the crystal lattice of NaCl crystal structure, where Na plus and Cl minus are adjacent to each other. Now, and I mentioned about the distance between them. Now, if you look at it, argon is an inert gas. For these inert gas, or those noble gases present in the 18th group, we find their radius by using the knowledge of van der Waals radius. So that was an extra information over here which I had to tell. Next, trends in the periodic table. Now if you see across the period, the atomic radius goes on decreasing. It is because new electron gets added to the same shell. If you observe, it is over here. If you want to know, lithium is 1s2, 2s1, then beryllium is 1s2, 2s2. So the new electron is getting added to the second principal quantum number shell, second main energy level. So the addition of electron is happening to the same shell. And with that, one more thing what you have to consider is the number of protons in the central nucleus is also increasing by 1. So more the number of protons, more is the inward pull. Therefore, these electrons will be more pulled towards the nucleus. So as you observe, across the period, the size of the nucleus goes on shrinking. So size of the atom goes on shrinking. So that is why across the period, you can see a decreasing trend in the atomic radius. Then down the group, when you observe this, down the group, the atomic radius increases. This is because new electron is getting added up to the new shell. For example, in lithium, it gets added to the second energy level, that is K is equal to 2, whereas in sodium, N will be equal to 3. In lithium, N was 2 because 1s2, 2s1, and in sodium it is 1s2, 2s2, 2p, 2p6 and 3s1. So it contains 11 electrons. So one more electron is added to the third energy level. So therefore, down the group, the atomic radius goes on increasing. Now, so we have discussed regarding the trends as well. So finally, I would like to thank you all. And in my coming videos, I'll be discussing about electronegativity and electron gain enthalpy. And for this videos, I'll be putting the link on the description of this particular video. Thank you very much, and please like, share and subscribe my channel.